All right. Like I just see that you're back. So I just mentioned that I'm really excited for you to giving this talk today because your work has really influential. I actually was utilizing the same task that you used in one of your experiments, the flight optimization task, which you used in the work on cognitive prothesis of goal achievement. And so I will conclude the introduction now. You have been leading the Rational Enhancement Group at the MPI for Intelligent Systems in Tübingen. I'm really happy to have you here now today. Before you start, one question, would you like to have questions during your talk or rather bundled at the end?
Maybe clarification questions during the talk and longer discussion questions at the end would be ideal.
That sounds great. So we usually have like 40 minutes for the talk and then maybe roughly 15 minutes for questions. And then if you have the time, it would be amazing if you maybe just could stay a little bit so that people who are not like have the option to drop out, but we also have the option to kind of talk a bit more in a, let's say, a more informal setting about what you're up to.
That sounds great.
Good. So the stage is yours.
Thank you so much for this kind introduction. I'm really happy to hear that. So I'll focus in this talk on the part of my work and our research that is about leveraging technology to improve human decision-making. I think at this point in time, people have a tremendous opportunity to do good in the world and shape the future in a positive way. But at the same time, we also have the capacity to do great harm. And many people are complacent and don't pursue their altruistic values very effectively. Therefore, the decisions that people make will have a big impact on the future of humanity at this time. And cognitive science can help us identify the mechanisms through which people make both good and bad decisions. And these includes both intuitive emotional mechanisms and also deliberate rational mechanisms. And I believe that educational, technological, psychological, and also regulatory interventions can shape those decisions in a positive way. And I think that those interventions should be informed by a thorough understanding of the underlying psychological mechanisms of decision-making and learning. There are three different kinds of approaches that we can pursue to improve human decision-making. We can improve people's decision-making literacy, which is known as boosting. We can change the environment in which people make decisions, and we can also give people tools that help them make decisions and do some of the decision-making for them. The different kinds of interventions lie on an autonomy continuum in terms of how much they either restrict people's autonomy or even enhance people's autonomy. At the low end of this continuum, we have laws that so strictly restrict what people can do. And on the other end of the continuum, we have boosting that increases people's capacity to make independent decisions for themselves by improving their decision-making competence and literacy. And in between, we have financial incentives and nudges retain people's autonomy, but influence people in sometimes subtle ways by redesigning the way in which decisions are presented to them, such that the intuitive decision mechanisms are more likely to choose the option that is desired by the architect of that choice environment. Recent work has found that both boosts and nudges can be used to promote social, pro-social behavior. In particular, donations to charities and donations to effective charities. In the example of boosts, that might take the form of educating people about how to evaluate the effectiveness of a charity that they consider donating to, and providing effectiveness information about the charities that people choose between. Nudges that have been applied to promoting donations include setting a high default value for the amount of donation, communicating social norms about how many other people of a related group have donated, and making emotional or moral appeals on the importance of making donations. Now, where there already is a lot of work on both boosting and nudging, I think there's still some fundamental theoretical questions and also practical challenges to positively influencing people's decisions at scale. Perhaps the most fundamental theoretical question that is not fully answered at this point is, how exactly should people make decisions? What is the good decision making that we seek to promote through boosting? Furthermore, it is also not completely known which boosts and nudges or tools are optimal for which kinds of situations and decisions. And on the practical side, the application of boosting in particular is limited by the very large amount of effort and creativity that is still required in order to develop good boosts and to discover clever decision-making strategies that people could be taught to improve their competence, and also the effort of teaching it to many people. So in this talk, I'll first address the fundamental question of what is good decision-making, how should people decide, and then building on that, I'll present some of our research on 3 approaches to improving human decision-making. First, boosting with automatically discovered heuristics, then boosting goal setting, and finally nudging goal pursuit. So on the question of what is good decision-making, I think that in the best case, good decision-making means pursuing altruistic values in a rational and effective manner, and thereby having a positive impact on the flourishing of humanity. Ideally, the decisions that people make would maximize the choice's positive social impact. And that social impact is basically a counterfactual, which is how much global long-term well-being there would be if you take the action, and how much global long-term well-being there would be if you did not. And since we don't know what exactly the consequences of any possible decision would be, we would always have to evaluate the expected social impact by averaging across all possible scenarios and weighing the positive impact on each of these potential future scenarios according to its respective probability. That would be a very extensive and intractable computation to perform, because there are just so many possible scenarios that we would have to consider. So if someone tried to use this principle of maximizing the expected positive impact in order to, say, choose a career, they would not have a career. In fact, they would be pondering that question until death, and basically would never be able to have any impact as a consequence of just spending all of their time trying to calculate the exact value of the expected positive impact of alternative career paths that they might pursue. However, there are practical strategies for identifying high-impact careers that fit people, and those rely on simpler, more heuristic decision criteria, such as asking a relatively simple series of questions that are easier to answer, such as, does this potential career path address one of the most important pressing global problems? And is this something that you could get really good at? These questions are still not easy to answer, but they're much easier for people to answer than calculating the expected positive impact numerically. This approach is consistent with prior work that found that there are a number of simple heuristics that allow people to make good decisions in the real world, and that those strategies can also be taught to people to improve their decision making. So this suggests that a practical approach to improving human decision making is to teach people clever heuristics that are well adapted to the kinds of decisions that people have to make in the real world. However, although we know some of those heuristics, there's a very large space of possible heuristics that people could plausibly use and that they would be able to use. To have some guidance as to which of these many possible heuristics we should teach people, I've developed a theory that I call resource rationality, which helps us identify the best possible heuristics that people could use in a given situation, given their limited time, their finite amounts of information that they have available to make decisions, and their bounded cognitive resources. This theory of resource rationality combines the insights from decision theory, such as expected utility theory, Herbert Simon's insights about bounded rationality, in particular, the importance of heuristics being adapted to the structure of the environment and people's cognitive constraints, and also the heuristics and biases research program's insights into the nature of people's cognitive limitations. All of these ideas are combined into a mathematical theory that allows us to formalize what constitutes optimal heuristics. And we can use this framework to derive optimal heuristics from first principles, and then we can use those heuristics to devise boosts that improve people's decision-making competency. An obvious way is to teach people these optimal heuristics that we derive from the theory of resource rationality. Another way in which the resource rational theory can help us improve decision-making is that it provides more accurate descriptive models of the processes through which people reach decisions. And we can then use these models to derive optimal nudges that create circumstances under which people's decision mechanisms lead to good choices. And furthermore, descriptive models of how people learn can be used to develop pedagogical interventions for teaching them better decision-making strategies and helping them learn how to select between them. The theory of resource rationality can be seen as a natural extension of expected utility theory, which is the dominant economic theory of good decision-making. That economic theory basically describes optimal behavior of idealized agents that have infinite computational power. By contrast, resource rationality defines optimal cognitive strategies and representations for real people with limited time and bounded cognitive resources. The prescriptions of these two theories are quite different. While expected utility theory says that people would entail that people should always consider all possible outcomes of all of their options and weigh them accordingly, the principle of resource rationality would recommend that people make efficient use of their finite time and limited mental resources. Formally, we can define a resource rational heuristic as a biologically feasible cognitive mechanism that balances the expected utility of the outcomes of the decision that will be made when that heuristic is used on the one hand, that's the first term, and the expected cost of the time and mental resources that would have to be expended by applying this heuristic in a particular situation or to reach a decision. So far, I've applied this resource rational theory to model many different aspects of cognition, ranging from planning to goal pursuit, judgment under uncertainty, decisions from experience and decisions from description, multi-alternative risky choice, strategy selection, cognitive control, proactivity, and they have also been applied to a few other cognitive phenomena. And in general, we find that they can capture adaptive aspects of human cognition that previous theories were not able to account for. So therefore, my first take-home message is that the resource rational framework is a promising approach for discovering rational heuristics and revealing some of the intelligence in human decision-making. However, I'd like to balance that by some of the more recent findings of our research comparing people's planning strategies and decision strategies against their resource rational counterparts. In particular, we find that while resource rationality captures many important qualitative aspects of human decision-making and also explains many aspects of decision-making better than previous models in a quantitative sense, there are nevertheless systematic deviations of human decision-making from resource rationality. In a planning task, we found that people's planning strategies were only about 80% resource rational, so they did not achieve the optimal balance between accuracy and cost quite as well as our resource rational model would have. In particular, we found that people are often biased towards forward planning when it would be more advantageous to think about the best possible long-term goal and then plan backwards from it. And in research on multi-attribute risky choice, we found that participants performed only about 63% as well as our resource rational model, even if we allowed the model to estimate people's cognitive costs. In that case, the main source of suboptimality appeared to be people's suboptimal strategy choices. So therefore, my second take-home message for you is that human decision-making still has some substantial room for improvement. That means that by moving people's decision strategies closer to resource rational heuristics, we would be able to improve people's decision-making in the real world, even within the bounds imposed by their cognitive resources, limited time, and limited information. Therefore, this principle of resource rationality could be a practical prescriptive theory for discovering heuristics that people can be taught in order to improve their decision-making. So having introduced this theoretical foundation, I'll now show you how we can apply it to improve human decision-making in different ways. And I'll start with our research on boosting decision-making and learning. So as I already mentioned, we can use the theory of resource rationality to derive optimal heuristics for human decision-making and then boost people's decision-making skills by teaching them those heuristics. And this is what I'll present in some more detail in the second part of my talk. Concretely, there are three ways in which we can use resource rational heuristics to improve human decision-making. The first is to construct decision aids that guide people through the application of a resource rational heuristic, basically taking them by the hand and leading them through the steps that the resource rational decision strategy would form. Second, we can teach them a resource rational heuristic and then let them apply it independently for themselves. And third, we can change the situation in which people make decisions in such a way that it becomes possible for them to use a more accurate decision strategy. For instance, by providing additional information that more accurate decision strategy requires. And in all of these cases, we can use our formal mathematical theory of what constitutes resource rational heuristics as a starting point for deriving optimal boosts. And I'll first give you some examples of how we use the theory of resource rationality to automatically design decision aids. So here, our idea is to use machine learning in order to automatically compute resource rational heuristics for a given model of a particular type of real-world decision problem, and some assumptions about people's cognitive resources that they have available to make those decisions. And then we apply some methods from interpretable machine learning in order to translate the automatically discovered heuristics into decision aids in the form of natural language descriptions or flowcharts. And then we present people with those decision aids and let those decision aids guide them through the decision process. As a first proof of concept that we can discover good decision strategies, we applied our method for strategy discovery to multi-atomic risky choice, where previous research by the ecological rationality community had already identified many smart heuristics, and we found that our method rediscovered to take the best heuristic especially those decision problems where it is most adaptive and most useful. And it rediscovered the weighted additive strategy as the resource rational strategy in high-stakes situations where multiple outcomes have similar probabilities. So these opposite types of strategies were discovered automatically as being the resource rational strategies for two different types of decision problems. So this was the first sanity check that our automatic strategy discovery method produces intuitive and useful results. And we then moved on to applying it to novel problems for which smart heuristics were not yet known. In particular, we studied the problem of planning. We started from the problem of planning a road trip, where you have to look up information about possible cities that you might visit, and then based on the information that you look up, select a route that combines some of those possible destinations so that you have the largest amount of enjoyment for the entire trip. And of course, there are so many cities that you could visit that it is not feasible to look up information about all of them, and there's a real cost of researching information about these possible destinations. To capture that in an experimental paradigm, we created this what we call a mouse lab MDP paradigm. Here, the task of the participant is to choose a route for the spider along the arrows to one of the outermost destinations. And the goal is to choose a route that has the highest sum of rewards along the way. So each of these gray circles has a hidden reward, and that reward can be uncovered during the planning process by clicking on the node. This video shows you the kind of data that we record of this paradigm and what planning looks like for the participant. So here the planning process consists of sequentially acquiring information about possible destinations that you might visit, and then integrating that information to choose a path. And different planning strategies will collect information in different orders, and they will also collect different subsets of information. Now, the question is, what is the resource rational heuristic for planning in this task, depending on what the distribution of possible rewards looks like? So we studied that for a number of different environments that are characterized by different distributions of rewards. And one particularly interesting one is the one where the range of possible rewards gets larger from each step to the next, so that the rewards are most variable at a most distant destination. That's a little bit like in life, where what you can achieve in the next 5 seconds has relatively small variation, but what you can achieve in the next 5 years has a very large range of possibilities. And our automatic strategy discovery method found that the optimal heuristic for those kinds of environments is what we call the future first heuristic. The future first heuristic, as illustrated in this video, plans by inspecting the possible final destinations first. And when it finds a final destination that is really good, then it selects the path that leads there. And it ignores the immediate rewards unless it has to distinguish between 2 equally good final destinations, which rarely happens in this particular environment. So now that we have discovered a few new heuristics that are resource rational for some environments, we test if we can use those to improve human decision-making by constructing decision aids that instruct people to follow those heuristics. And in particular, here you see the output of our AI interpret method for generating procedural descriptions in natural language. So the text here shows what the automatically discovered natural language description of the heuristic according to our method. It says, click the destinations representing the most long-term consequences that have not yet been examined. and then repeat this step until all long-term consequences are known, or the most recently observed destinations uncovers the most valuable consequence, which is 48. This is a description that people can intuitively follow, and it improves people's performance. Furthermore, the same kind of strategy also is a resource rational approach to planning in more naturalistic, more complex tasks, such as this road trip planning paradigm, where participants use a search engine to look up the hotel prices at different potential destinations that they might spend the night at on their path to one of these airports. And at the airports, again, the prices are most favorable. So in this case, the automatically generated decision aid reads like the text above here. And similarly, for choosing between mortgages, the future first heuristic recommends that people should first check the interest rate, the amount of interest that they have to pay in the longest and most distant time period at the end. And all of these descriptions that advise people about the optimal strategy for these different decision problems were automatically generated by our method. And then we conducted experiments to see the quality of people's decisions with versus without those automatically generated decision aids. And here in these graphs, you see that the condition shown in orange that was supported by the automatically generated instructions performed significantly better at both of these naturalistic decision problems than the control group that practiced this task without being supported by instructions. So this is very encouraging first data suggesting that our automatically generated decision aids can improve human decision making in naturalistic decision problems. A second approach to boosting human decision making with resource rational heuristics is to teach people resource rational heuristics and then let them use them on their own. So to achieve this, we have developed some intelligent cognitive tutors that teach people the automatically discovered heuristics by giving them feedback on the way in which they make decisions in certain practice problems. Our tutor observes which strategy the person uses, and then it gives them optimal metacognitive feedback on the way in which they reach the decision. And that feedback is designed to maximally accelerate their learning towards the optimal decision strategy for the kind of problem that they're currently solving. The feedback was derived from methods that were originally created to accelerate reinforcement learning in robots. But the same principle we found is also helpful in humans. And the gist of the resulting feedback mechanism is that for each information acquisition that people make, so for each piece of information they look up, they should get a feedback signal that is proportional to how much that piece of information improves the decision minus the cost of acquiring and processing it. Now I have a video that shows what it's like for participants to practice planning with our intelligent cognitive tutor in this environment where the rewards have an increasingly larger range from the first step to the second step to the third step. So you can see this was the first click that a participant made, and they got some immediate feedback that has two components. They get a delay penalty that is proportional to how suboptimal that planning operation was. And they also get a hint telling them what the optimal strategy would have done differently. Namely, the optimal strategy would have clicked on one of these final destinations. This is the second trial. You see the participant has already learned something, but I haven't mastered the strategy completely yet. And in this third trial, they made the worst possible mistake. They tried to act without any planning. And then they get a very large negative feedback that usually encourages them to never make that mistake again. We found that with this optimal metacognitive feedback, participants very rapidly discover the optimal resource rational strategy that our tutor was teaching. And furthermore, they perform significantly better on the test of their decision-making skills that is administered after the training session. And they perform better not just compared to a control group that practices without feedback, but also compared to a control group that receives regular performance feedback, such as wrong choice, you should have moved up, you should have moved up rather than right. That is the conventional way of feedback that people would receive during training, and that is not nearly as effective as our metacognitive feedback on the process for which people arrive at their decisions. Furthermore, we find that people transfer the taught strategy to more complex and more naturalistic tasks, such as from this simple three-step task to the more naturalistic road trip planning task. Again, significantly improving people's performance on the transfer task after the training is over. And we also found a way to apply this metacognitive feedback method directly to real-world problems. So for instance, we created an app that gives people feedback on how well they stay on task while they're trying to work on their computer. So whenever they get distracted, they get negative feedback. When they reorient their focus towards the chosen activities, they get positive feedback. If they stay focused for a long time, they also get positive feedback. And here you can see that how well people stay focused increases rapidly in the experimental group that receives the optimal feedback, much more so than in a control group that practices staying focused without feedback. And we have many sort of additional findings and extensions of this approach to discovering and teaching resource rational heuristics automatically. We have research on making this method more robust, making it more scalable, and applying it to more complex environments that have substantial amounts of ambiguity and uncertainty as well. So my third take-home message is that deriving boosts from the principle of resource rationality is a promising approach to improving human decision-making. Another way in which we can boost people's ability to learn good decision-making strategies is by guiding them to reflect on their decision-making, basically a guided discovery approach, similar to what Socrates did in order to help his students gain wisdom. We guide people through 4 levels of reflection. First, we have them describe the process for which they reached their decision. Then we have them judge how well that decision strategy worked out for them. And then we have them formulate a lesson that they want to, about how to improve their decision-making strategy based on what they did and how it worked out. And then we have them plan to apply that lesson. And in a pilot experiment, we find that this kind of reflection substantially boosts the speed at which people discover adaptive planning strategies. So here, for instance, after the first reflection, there was a big spike in the proportion of people who subsequently used the resource rational planning strategy for this larger environment. And in the future, I'd like to investigate whether this systematic reflection can also help people learn more effectively from their experience in the real world. So the idea is to give people a Socratic app on their cell phone that has them reflect on their real life decisions and how those turned out and why. And by doing so, people might be able to discover increasingly more resource rational decision strategies in the real world. And that could be used to design new training programs for decision-making and problem-solving skills for in educational and also in organizational context. And it might also help people steer away from maladaptive ways of decision-making that are associated with mental disorders such as addiction and obsessive compulsive disorder, and with pathological gambling and societal issues such as crime and violence. So it could be used potentially to prevent people from developing these maladaptive ways of decision-making by helping them realize that the ways in which they're making decisions lead to outcomes that are not good for them, and therefore steer away from maladaptive ways of decision-making before those become serious mental health issues. So this was the part on boosting decision-making and learning. I noticed that I don't have very much time left, so I probably skip one of the later parts. Do you have a preference for either hearing about boosting goal setting or nudging goal pursuit? Nudging goal pursuit has a bit more artificial intelligence in it, if that is a plus for you.
Yeah, then that sounds great, I guess.
Okay, then I'll go for the fourth part. Okay, so optimal nudging. So nudging, we are not changing people's decision-making strategies, but rather we're changing the environment so that people's intuitive decision strategies lead to better outcomes. We can again formalize this within the principle, within the theory of resource rationality, by saying that we're trying to find the modification to the current decision-making environment such that the intuitive heuristic that people use has the highest resource rationality in the modifying environment. And we apply this in the domain of choosing what to work on to address a very familiar problem, namely that people often procrastinate on important but unpleasant things, while finding plenty of time for pleasant but not so important things. This problem generally arises from a misalignment between how pleasant a task is in the short term and how valuable it is in the long term. So this appears to be a really fundamental problem and bias in human decision-making that results in people having motivational issues when the short-term rewards are misaligned with long-term value. Therefore, a way of redesigning the environment that would make it much easier for people to make good choices would be to align the short-term rewards of each action with its long-term value, so that what is most valuable in the long run is also most appealing in the short run. We formalize this as adding some so-called pseudo-rewards F to the reward structure of the environment in such a way that the myopic decision strategy that chooses the action that yields the highest immediate reward makes the same decision as the optimal far-sighted decision strategy. And we can automatically compute those optimal incentives, and the solution has the intuitive form of being the expected value of the state that taking this action will lead you to minus the value of the current state. So with this approach, we then designed an app for AI-powered optimal nudging that changes the way in which decisions are presented to people, so that people's short-sighted decision mechanisms will choose the option that is best for them in the long run. Intuitively, this corresponds to changing the framing of the decisions from choosing between something that is fun and easy and something that is dry and daunting to something that gives you more points now because it's more valuable in the long run versus something that gives you fewer points now. Concretely, we apply this approach to to-do list gamification. we model the goals that people have and the tasks that they have to complete to achieve those goals as a Markov decision process, where each action is a task choice, and the state reflects which tasks have already been completed and which have not yet been completed. We then compute the optimal value function for this Markov decision process on a web server and use it to compute the optimal incentives for the individual tasks and add those to the participant's to-do list. And with that gamified to-do list, the participant can now simply choose the task that gives them the largest number of points right now, and they will be on the optimal path towards achieving their long-term goals. We evaluated this approach in a series of online experiments. In these experiments, all participants have a number of daunting writing assignments that are due by a distant deadline, and they are only rewarded after the deadline. In the experimental group, the to-do list is augmented with the optimal point values calculated by our method, whereas in the control group, no points are shown and people have a regular to-do list. We found that optimal gamification reduced the proportion of participants who procrastinate from 40% to only 15%. And furthermore, in a subsequent experiment, we found that optimal gamification also increased the proportion of people who prioritize the most important project from only about 2/3 to 89%. So it helped people both to overcome motivational obstacles and procrastinate less, and also to prioritize better. So my last take-home message, therefore, is that AI-powered self-nudging can help people overcome motivational obstacles and pursue their goals more effectively. And note that this is an approach that helps people nudge themselves towards their own goals, rather than an approach where some external company is trying to influence other people. So to conclude, in the first part of my talk, I argued that resource rational modeling is a promising approach to discovering good heuristics for human decision-making. In the second part, I showed you that human decision-making, human decision-making has room for improvement, and that deriving boosts from the principle of resource rationality is a promising approach to achieve those improvements. In the part that I skipped, I would have told you that psychologically informed technologies can help people translate their values into goals and then plan how to achieve those goals. And in the last part, I argued that AI-powered self-nudging can help people overcome motivational obstacles and pursue their goals more effectively. With that, I'd like to thank my research group, our funders, and also our collaborators and the MPI for Human Development for supporting my ESC starting grant application. Thank you very much, and thank you for your attention. I'm happy to take questions.
Thank you. That was super fascinating.